These are solutions to Milham's Calc 3, exam number 3. Sorry, I'm not using the headset, so you may not be able to hear me as well, or the way it was at the beginning of the semester. Before going on, I'll also mention that the first time I made the solution set, my solution key, I messed up again, but you all know that there's nothing new. And I realized some of the numbers came out pretty bad. I didn't expect some of the numbers, especially the radicals, to come out to be so weird. So I took that into account when grading your exam. And you did not have to get every single question correct to get full credit, or you didn't have to, maybe I should say, you didn't have to get everything correct on a particular problem to get it right. If you were close, maybe a very small mistake or a minor mistake, that is something that I could have done, then I may have forgiven it and still given you full credit. So just because you got 10 points on a problem does not mean it was completely correct, but maybe you made a forgivable, quote unquote, mistake. All right, so with that in mind, here we go. Okay, number 1. So x squared plus y squared is not equal to 16. What you did need to show me is a circle, center of the origin with a radius of 4, and it should be a dotted circle. You should not have a solid circle and shade everything else. That's a normal way to indicate that, even back in algebra 1, right? So some of you did some other funny algebra which doesn't work, like somehow became a line or whatever. And not equal to 16. Some of you maybe shaded only the inside or only the outside. No, everything is shaded, just a dotted circle on this x squared plus y squared equals 16. So that would be the domain. Number 2, you just had to show 2 different paths with different limits. Some of you didn't pick the ones that I picked, which I thought would have been the easiest. But if you picked any other path or paths, 2 different paths to show that the limit was different, then that would be sufficient. So along y equals 0, then the limit comes out to be x squared over x squared, which is 1. If you go along x equals 0, then the limit comes out to be 0 divided by y squared, which is 0. So 2 different paths with 2 different limits, therefore the limit doesn't exist. Okay, number 3, this is fx, 3x squared y squared minus 9x squared y to the 4th. Fy is 2x cubed y minus 12x cubed y cubed. Fxx, 6xy squared minus 18xy to the 4th. Fyy, 2x cubed minus 36x cubed y squared. And the mixed partials, fxy, 6x squared y minus 36x squared y cubed. And as a double check, if we did fyx, you get the same thing. Number 4, fx is negative 2x, fy is 2y. Some of you forgot to plug in. You left it there. You have to plug in. So plug in 5, negative 4, that gives me negative 10. Plug in 5, negative 4, that gives me negative 8. So z plus 9 equals negative 10 times x minus 5 minus 8 times y plus 4. A little bit of algebra, which I messed up. 10x plus 8y plus z equals 9, or any equivalent form. Number 5, dw dt is the partial of w with respect to x times dx dt plus partial of w with respect to y dy dt plus the partial of w with respect to z dz dt. All right, it's best when you differentiate to treat this as x e to the y z to the negative 1. So partial of w with respect to t is e to the y over z times 3t squared plus x over z e to the y over z times negative 1 plus negative xy over z squared e to the y over z times 6. And you can clean it up if you wanted to, like that. dy dx is negative fx over fy. Some of you had fy over fx. Some of you maybe forgot the minus sign, so you may have lost a point or 2 on that. But anyway, negative 2x plus 3y over 3x plus 3y squared. Number 7, unit vector is negative 4, 7 over radical 65. Del f is 2 radical y. 2x times 1/2 y to the negative half comes out to be 2 radical y, x over radical y. Plug in 2 and 3. 2 radical 3, 2 over radical 3. So it comes out a little bit clumsy. So the derivative f in the direction of u is del f dot u. 2 radical 3, comma 2 over radical 3 dot negative 4 over radical 65, 7 over radical 65. It was messy. You can see I messed up. So I would have accepted anything semi-reasonable. If you had that, I would have left it. It looks like the best final answer is actually negative 10 over radical 195, which some of you had. And I got eventually, but you can see I messed up quite a bit here. Okay. And number 8, I messed up the first time I did it, but what else is new? All right, so del f is 1 negative z over y squared, 1 over y. Okay, f of x, y, z is x plus zy to negative 1. Okay, so del f at negative 4, 2, negative 1 is 1 negative of 1 over 4 and 1/2, or 1, 1/4, 1/2. They're all positive. So you got one of them negative. I may have taken up the 22. Okay, so the maximum value is the magnitude of this vector, which is radical 1 plus 1/16 plus 1/4. Comes out to be radical 21 over 4. The direction is the direction of the gradient vector, 1, 1/4, 1/2. You did not have to make it a unit vector. Okay, it would have been nice to make it integer components, or 4, 1, 2. Some of you did that, so that's fine. Okay, number 9. Fx is 2x plus y squared. Fy is 2y plus 2xy, which factors into this. Okay, fxx is 2, fyy is 2 plus 2x, and fxy is 2y. So the d is fxx fyy minus fxy squared, 4 plus 4x minus 4y squared. If I set fy equal to 0, I get y equals 0 or x is negative 1. If y equals 0, then that forces x to be 0. So 0, 0 is a critical point. And then if I plug in x equals negative 1, y squared equals 2. So y is plus or minus radical 2. So my critical points are the origin and negative 1 plus or minus radical 2. And f of 0, 0 is 1. That is a minimum. The d, if I plug in the origin, so put a 0 there and a 0 there, I get 4, which is greater than 0. And fxx is 2. That means I have a minimum. So f of 0, 0 is 1, which is a minimum. Okay, and then the d at negative 1 plus or minus radical 2 is 4 minus 4 minus 4 times 2. That's plugging in here. That's less than 0. So these are both saddle points. Okay. You really should put the function value. Okay, but I excused it because I know the book didn't do that. But you're asking for points. Okay, a 0, 0 doesn't count as a point. Remember, you have to give the z coordinate. Okay, so f of 0, 0 equals 1 is the minimum. That really means the point 0, 0, 1 with a height of 1. And let's see, I didn't take off for that because the book didn't do that. But if you plug in negative 1 plus or minus radical 2, it should come out to be 0. Okay, so f of negative 1 plus or minus radical 2 is 0. Those are saddle points. Okay, and I completely botched that, so don't even look at that. Okay, number 10, del f is lambda del g. So negative yz, negative xz, negative xy is lambda 6x 4y 2z. Okay, so system of equations, negative yz equals 6x lambda, negative xz equals 4y lambda, negative xy equals 2z lambda. Now, I actually didn't show you how to do one of these kind of problems. Okay, but a nice trick is to multiply this one by x, this one by y, this one by z. So they're all negative x, y, z. Since they're all negative x, y, z, they have to be equal to each other. So 6x squared lambda equals 4y squared lambda equals 2z squared lambda. Okay, that means lambda can equal 0. Okay, if lambda doesn't equal 0, you can divide out the lambda and you have 6x squared equals 4y squared equals 2z squared, or 3x squared equals 2y squared equals z squared. Okay, let's think just for a moment if lambda equals 0. Okay, if lambda equals 0, that means all of these are 0. That means either x or y or z has to be 0, which means the function value is 0. Okay, the original function f of x, y, z is negative x, y, z. So the function value is 0. And we know we're going to get a positive and a negative quantity. So this will not maximize or minimize my quantity. Okay, so replace 3x squared with z squared in the original and 2y squared with z squared in the original. So you end up with z squared plus z squared plus z squared equals 6. 3z squared is 6. Z is plus or minus radical 2. And since z squared is 2, I have 2y squared equals 2. That means y squared is 1, y is plus or minus 1. And 3x squared equals z squared, which is 2. X squared is 2/3. X is plus or minus radical 2/3. So my ordered triples are plus or minus radical 2/3, plus or minus 1, plus or minus radical 2. Okay. So to maximize, and some of you didn't include this, so I had to take off for that. But I realized I didn't talk about any of those. but it's still a fair question. Okay, if they're all negative, f of negative radical 2/3, -1, negative radical 2, that's 2 over radical 3, or any combination of 1 negative and 2 positive, which some of you had. Okay, so in other words, if one of these is negative and 2 of them is positive, that makes the whole expression positive, and so you'll get 2 over radical 3 also. And minimum is if they're all positive, f of radical 2/3, 1 radical 2 is 2 over radical 3, or any combination of 1 positive and 2 negatives would also give it to you. Okay, I guess I should put a negative there. So even in my adjusted answer, I messed up, but I just fixed it right now. Okay, so it should be a negative here. Okay, and once again, lambda equals 0. Okay, if lambda equals 0, okay, if you look at the original equation, that means either x or y or z has to be 0. The original function would be 0. So that doesn't give me a maximum or minimum, since I already have some function values at 2 over radical 3 and some at -2 over radical 3. All right, so that was the solution key for Melham's Calc 3, exam number 3. And I'll try to grade you somewhat leniently because I messed up again.